and you configure a traffic shaping policy. That traffic policy can be determined on a specific policy and specific categories such as video and audio, where you can actually select different applications such as the Netflix application. Fortigate Captive Portal in 3 minutes. Here's how. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. So you have outsourced employees connected to one of your interfaces and you wish to restrict the access to the network. What do? You use Captive Portal. How? Here's how. The first thing to do is to create a new user group, a user group that is dedicated to those outsourced employees. So let's create one. Let's use the guest as our user group, and let's use email as a method to deliver the password for that captive portal. The expiration of the account is 4 hours, but you can change it. That's the first step. The second thing to do is to create an administrator that is responsible only for the provisioning of the guest accounts. So let's use my name, let's use a password, and let's restrict that admin for guest accounts for the outsourced employees. Now the third thing to do is to head over to that interfaces that our employees will connect through, and let's move over to the security mode. Let's choose, usually it is none. Now we will use Captive Portal. We will restrict it to that outsourced employee group, and we finish the third step. Let's create a policy that will allow outsourced employees to get into the network, and outsource EMP. The incoming interface is the interface of the outsourced employees. The outgoing is our WAN. Source will be all and will be outsourced employee user group. Destination is all. Service is all. All right. Now let's log out and let's get into the new admin page that will allow us to create password for those employees. Now let's use my email, and Fortigate will generate a password that we can print it out or send it via email. Now if we log out again and enter with our user, our super admin credentials, we will see that in our user group, we already have one member, which is the member that we have sent the password to that email. Hey everyone, this is the second part of how certificates work. We will unleash the mystery of certificate, and in this part we will look at asymmetric encryption. Well, asymmetric encryption works using a key pair, two different keys that are related mathematically. Now, one key, which is the private key, should be kept safe. That's the secret key. The second key is a public key. Anyone can use it, anyone can look at it. You can encrypt using the private key or using the public key. You cannot encrypt and decrypt using the same key. You have to use the second pair in order to encrypt or decrypt. Now, we will look at OpenSSL and how do we generate a key pair. One is a private key and the second one is the public key. But the beauty of asymmetric encryption or using a key pair is the fact that they're not only used in encryption, they are also used to authenticate the identity of the second peer. A server that wishes to have a digital certificate must generate a key pair. It must generate a public key and a private key. There are different algorithms that will allow it to do so. We will use RSA. Now we'll use OpenSSL, GenRSA, and let's name our key pair. Let's name it Fortigate, and let's contain it in a PM format, which is a container that will include both keys. And let's decide that the size of the keys will be 2048 bit. And that's about it. Now, if we wish to see both the public key and the private key, to inspect them individually, we can do so using the following command: OpenSSL RSA. Let's insert the file that we have just created, fortigate.pm, and let's get the public key out of it, and let's name it mykey.pub. All right, it's writing it. Let's see how it looks. Let's open the key, and that's our public key. Now, if we wish to see the private key, we can use the following command: and that's the private key. So we have a public key and a private key, and those two are used when a server requests a certificate using a certificate signing request. It sends the public key as a part of its information. We will look later on how a certificate authority takes that information and actually creates a digital certificate plus a digital signature that will prove that he or it is the one that it claims to be. Hey everyone, back to Fortigate certificate, and in this part 3 we will look at hash functions. Now, what is a hash function? A hash function is a mathematical function that takes any input and produces a hash value. Now, the hash value is always in a fixed size according to the hash function that was used. The hash value is also called a digest, and it should be impossible to produce the same value for two different inputs. So the function is actually collision free. Now, a hash function must be quick. It has to produce the hash value very fast, and a slight change on the input should change the entire hash value completely. So even if we have a 1 gigabyte file full of text and we change a comma in one of the sentences, the hash value will change completely. So we have the input, we have the hash function, and we have the digest, the hash value. Now, when do we use it? We use it for integrity. Whenever we send a file, it can be just about any file, and we want to check its integrity, that no one touched it, no one tampered with the bitstream. We make a hash value out of the file, and then on the other side we compare the same file using the same hash function. If the two hash values are the same, then no one tampered with the file. If the hash value changes, then someone probably touched the file. There are dozens of hash functions that are used just about anywhere. When a web server stores passwords in its database, they are being hashed. They are being hashed using different hash functions such as the SHA-256 or the SHA-512. To make the hash stronger, we also use what is known as a salt. We generate random numbers to be added to the password itself, and thus the hash value will be much more difficult to guess. Now the term guessing is the right term, since hashes are in no way an encryption technique. They are not used for encryption. They are only a mathematical function, a one-way mathematical function that takes an input, turns it into another value, and there's no way back. They are not reversible. Alright, so enough with that. Let's move over to OpenSSL. Let's reproduce some hashes out of different inputs. And at the end, that will probably be part 4 of the series. We will recap what we have learned by now. That is symmetric encryption, asymmetric encryption, and hash functions. And we will look at certificate, a digital certificate, and understand how it all matches. Alright, so we'll use OpenSSL, but let's start out by using the echo command. And let's write down some text. I have a secret message. Alright, now let's grab it into OpenSSL. And let's use MD5. MD5 is a hash function that produces a 128-bit value. Now that's the hash value of that text. Now if I'll use the same text, but I'll change the E to an A, you'll see that I get another hash value, completely different hash value. Let's go back to the same text, and it will produce the same hash value as before. Now if we will use the SHA-256 hash function, you can see that we actually get the output as a 256-bit value. It is much stronger than MD5. We can also do it using the 512-bit, which produces stronger hash value. Now, how does it all have to do with digital certificate and digital signatures? We will look at it in our next video, which will be the last part of the series. But let's just look out at a digital certificate. And as you can see, we have the public key, which is the asymmetric encryption. We also have a signature algorithm, which is the hash function, as we just spoke about. And in part 4, we will see how it all mixes out with the symmetric encryption to make sure that we have confidentiality, authenticity, and integrity. One of the toughest topics to understand when we deal with security appliance is probably the world of certificates, a digital certificates. Why? Because understanding certificates means that you have to understand what is asymmetric encryption, asymmetric encryption, and hash functions. Now, we will start with a video series that will try to lighten up the issue, and we will start with a basic introduction to symmetric encryption. We will do it using OpenSSL. So asymmetric encryption means, and that is the very basic meaning, that we take a plain text, we use an algorithm, which is a mathematical function that uses substitution and uses transpositioning, and we are using a key that is known to both parties. The key is the same. Later on, we will deal with the key space and what does it mean. And now we will take the plain text and we will use the algorithm together with the key to turn it into a cipher text. So if we'll open up a text file and let's write down Fortinet secret key, and now let's save it. Let's save the file as Fortinet. Let's open it again just to make sure that we have the plain text. And now let's use OpenSSL. Let's use AES 128. AES is a symmetric encryption algorithm. In our case, we are using a key space of 128 bits. That is 2 to the power of 128. And let's insert the Fortinet text and let's output as cipher text. Let's call it Cipher Fortinet. We are asked to insert a password. The password is not the key. The password is part of the key derivation. So let's enter the password. Let's enter it again. And now we have a ciphertext. Let's look at the ciphertext. We have called the ciphertext Cipher Fortinet. And there it is. That's the encrypted plain text. Alright, so here we are at the top 5 diagnostics command for your Fortigate, and we start with the first command, which may look a bit simple, which is the get system status. Now this command is very basic, but it gives you a lot of information. It gives you the virus and IPS database version. It gives you the serial number of your Fortigate. You can tell if you have a hard disk or are you using only a flash memory. It also tells you, are you participating in an HA cluster or not. It gives you information of the operation mode. Are you working in a NAT mode or maybe a transparent mode? Are you using another virtual domain or are you using only one virtual domain? So a lot of information in that simple command. This second command is the get hardware NIC and the interface name. In our case, let's look at our WAN interface. Sorry, it's WAN1. And that tells you of each interface its MAC address. Does it support any hardware acceleration? In our case, we support MP4 Lite. Do you have any dropped packets in your interface? Is the status up or down? Are you working in a full duplex or maybe half duplex? And what is the speed of your interface? In our case, it's 1 gig. Our third command is the get system performance status. Now, personally, I love that command since it tells you a lot of your Fortigate. Now, at the top output, you will see how many CPUs your Fortigate module supports. The following thing is the RAM usage. And at the bottom, the output shows your network traffic, the amount of average sessions per minute, and so on. So you have your CPU usage, you have your RAM usage, and your network usage. Next up is probably one of the most known when you deal with the Fortinet firewall, and that is the diagnose debug flow, which actually shows you the flow of your traffic from the CPU perspective. So you have to enable it. Let's enable. And then you use the diagnose debug flow. You usually use filters, since if you're not filtering your traffic, there could be tons of traffic that will be shown on your command line and it won't be so easy to analyze. So let's filter a specific address, which is the 10.0.3.16. And now the next thing to do is to diagnose debug flow and trace. And let's use a count of 10 packets to show. And it shows us tons of information from the specific source host that we have chosen to just about anywhere that the traffic flows. It shows us the source NAT and the destination NAT, and it shows us the policy that is being used. A great tool for debugging and troubleshooting. Alright, now the next command is the diagsys session list, which shows you the sessions that are being handled on your Fortigate, and that also shows us tons of information. You can see the different protocols that are being used. You can also use it using specific filters or grabbing different source address, and that will show you a limited portion of the information that is relevant towards a specific host only. And Our last command is the diag which is similar to the top command in Linux, and that shows you each and every process in your Fortigate. It shows you the process name, the process ID. It shows you its state. Is it asleep or maybe it is running? It shows you how much memory is being consumed and how much CPU is being consumed. Whenever you have issues with one of the processes in your Fortigate, that is probably one of the first places to check. And before we end this video, please don't forget to subscribe. Your Wi-Fi throughput can vary for different reasons. Noise, misconfiguration of the access point, co-channel interference, adjacent channels, and so on. But one of the main reasons is obstacles in your physical space. Obstacles that will make your RF signal reflect and propagate to different directions. One of the mechanisms that are used in Wi-Fi is the guard interval. It protects symbols in your packets from getting back and damage other symbols. Mostly we use a guard interval of 800 nanoseconds, but since 802.11n we can also use short guard interval of 400 nanosecond. It can help you increase the throughput in your Wi-Fi deployment, but don't use short guard interval whenever you have high density deployment. Let's try it out, and please comment me back on this video and tell me if it helped you to increase your throughput. I can tell you that in my case, it actually helped me to increase my throughput in about 10%. So let's do it. So let's move over to the CLI. Let's configure the wireless controller WTP profile. And now let's edit one of the most used access points, which is the 4221. Let's configure its radio. Alright, let's see the full configuration. And as we can see, the short guard interval is disabled. So we can set the short guard interval to be enabled. That's about it. Now, don't use it in any deployment. Learn what happens in your network in real time and make decisions by it. Hey everyone. So you have your Fortigate and its switchboard includes physical ports. Each can be configured with its own IP address or be associated to a virtual switch, either a soft switch or a hardware switch. That is, we are actually creating switches within the physical switchboard. But what is the difference between a soft switch and a hardware switch? Well, the difference is that in soft switch, the implementation itself is done at the software level and not on the hardware level. That is similar to saying, okay, port 1, port 2, port 3, you all belong to a soft switch that we will name it marketing, and it will have an IP address of 10.0.0 and so on. In a virtual hardware switch, the implementation is done over the physical ports themselves, where each port, each interface is configured in its hardware level to be a part of the same hardware switch. That is a much superior way to handle traffic, and in terms of performance, it makes a huge difference. Now, whenever a traffic enters the switch and it is destined to one of the interfaces that belong to that switch, decisions are made by the physical switch itself, its forwarding table, which is actually the MAC table. Alright, so let's configure a hardware